So we'll be discussing all the concepts of rotational mechanics today, including center of mass, how to find center of mass for a two-body system, for n-body system, then equation of motion of system of particles where center of mass is the representative of all the particles. So basically we are going to discuss motion of rigid body. From system of particles to rigid body we will teach. This rotational mechanics, the first topic is center of mass. What is center of mass? Just consider a two-body system. Two-body system situated in two-dimensional or three-dimensional space, whatever you say. Position vector of first mass is at R1. Position vector of second mass is at R2. Three-dimensional coordinate system. So center of mass of this two-body system is defined as M1 R1 plus M2 R2 by M1 plus M2. Okay, this is true for a two-body system. R1 R2 are the position vector of two particles. Now for a three-body system or for a n-body system, center of mass is defined as M1 R1 plus M2 R2 plus Mn Rn, that divided by M1 plus M2, this way up to Mn. Okay. Now what is the Cartesian equivalent of this thing? If you find the position of center of mass, the x coordinate, x bar will be what? M1 x1, M2 x2. For n-body system we are writing, it will be Mn xn by M1 M2 Mn. Y bar will be what? M1 Y1 M2 Y2, this plus Mn Yn by M1 M2 Mn. Similarly we can define z coordinate also. This is M1 Z1 M2 Z2 Mn Zn by M1 M2, this way Mn. You can simplify writing this if you write sigma mi Ri by sigma mi I equal to 1 to n. Here also I equal to 1 to n. Okay. Now let us see one problem here where it is given that a particle of mass 2 kg situated at the point 3, 2, minus 1 and 3 kg situated at 1, minus 2, minus 3. Find the position of center of mass. No need to find x, y and z coordinate. You will be writing R1 vector here. R1 is 3i 2j minus k. R2 vector is I minus 2j minus 3k. So center of mass will be what? M1 R1 2 into 3i 2j minus k this plus the second mass is of 3 kg, 3 into I minus 2j minus 3k divided by 2 plus 3. So position of this vector method is always useful more than that of xyz coordinate. Okay, we'll be deriving every relation in terms of vector, because once we do it in terms of vector, that has consequence in along x-axis, along y-axis, along z-axis. Particle system of particles motion along x-axis you can consider separately if you have no idea about y and z-axis. But from vector form you can get every idea. So what is the position here? This is going to be 6 plus 3 9i, 4 minus 6 minus 2j, and minus 2 minus 9k minus 11k divided by 5. So center of mass will be at 9 by 5 minus 2 by 5 minus 11 by 5. No need to get their x, y and z coordinate. Okay. Now position of center of mass we can find for system of particles. If you go from system of particles to rigid bodies, how do you find? This for n body system we can find by the same method. How to find center of mass for rigid body? Center of mass for rigid bodies. For a rigid body, this is, what do you mean by rigid body? Whose distance between two particles cannot be changed by the application of external deforming force. That is called a rigid body. This one is a rigid body. Assume. How do you find the position of its center of mass? You select an elemental portion of it, dm mass, and then find center of mass by this formula: x bar equal to integration x dm by total mass, y bar given by what? Y dm by total mass, and z bar given by z dm by total mass. For one dimensional object, you take it along x-axis, use this formula. Okay, you can get the position of center of mass. But center of mass calculation, you will do it for a rigid body. You do it for a straight, uniform rod of mass m, certain mass and certain length. But I will be showing you that in some school exam they ask question on center of mass of semicircular ring, center of mass of circular disc also, semicircular disc. If you go for finding center of mass of a ring, where does it lie? We will not derive the result. Center of mass of a ring, uniform ring obviously, this will lie at geometrical center. Okay, in class 11 no need to derive it. Okay, this is number 1, geometric center for a ring. What is the center of mass of a sphere lies? Center of mass of a sphere will be at the geometric center. For a sphere, so center of mass of a ring at the center, center of mass of a sphere will be at the geometric center. What is the centrum mass of a cylinder? Cylinder is solid only. Yeah? For a solid cylinder, where does the centrum mass lie? It will be lying at the midpoint of the axis. This is the axis of cylinder. Centrum mass will be lying at the center. Okay, this one is a solid cylinder. Same is for hollow cylinder also. Okay, centrum mass of a rectangular plate. This is centrum mass of a no calculation required. Okay, for your class 11 school based examination, competitive exam, the derivation not required, but where you need derivation, I will be discussing those kind of problem, okay, which you have to derive. So here centrum mass lies geometrical center. For a rectangular plate, this information is required. This for a rectangular plate, where does the centrum mass lie? The centrum mass will lie at the point of intersection of the diagonals. This is for a rectangular plate. CM lies at the geometric center. Okay. Now let us calculate centrum mass in the following cases. This is required. By using the concept of centrum mass of rigid body, you answer these three questions. Find question number 1, centrum mass of a solid uniform rod of mass m and length L. Question number 2, this is uniform, solid uniform rod. If the linear mass density of a rod varies with distance x as follows. What? That is rho. Rho is the linear mass density. Rho x equal to 2x plus 3x square. With distance, it varies according to this relation. If the length of the rod is equal to say 20 centimeter and mass 2 kg, find the centrum mass. Question number 3, find the centrum mass of a semicircular ring of radius r. Also find the CM of a semicircular disc. center of mass of a semicircular disc. Let us solve these 4 sums one by one. If you find this one very easy, you can start with number 3, but let me do it step by step. Okay, do this one. For a semicircular ring of radius r, number 1, center of mass of a solid uniform rod. Thickness we normally don't consider. For this solid uniform rod, its mass is m, length is l. This is a one-dimensional object. So do we need y bar and z bar? No, only x bar. How to get it? The concept is the rigid body will be divided into infinite number of small parts. For an elemental portion, we take its mass, multiply by x coordinate, divide by total mass. Okay? Center of mass is not mathematical concept. We calculate by using mathematics, but it has huge significance for system of particles and rigid bodies. So we are doing the mathematical part now. The importance of all these things you will come to know once I extend. And this was the first question in today's class. Explain how it can be done it for, I mean Newton's second law of motion can be used for system of particles. Okay, can it be used? This is a theoretical concept, conceptual question you have to understand. But this calculation you need to remember the result. How to do it? The center of mass will be dividing into small parts. Dx is the elemental part at a distance x from this end. Mass of this elemental portion, this is the elemental portion, dm equal to mass of the elemental portion. This is equal to m by l into dx. You agree? Mass per unit length into dx. So is the formula. Only x bar exists. Y bar 0, z bar 0, because it is a rod is one dimensional object. It's a one dimensional object. So x bar will be what? X into dm by total mass. You have to multiply by x. This is the formulation. X means x only, dm means m by l dx, this by m, and then you have to integrate it over the whole solid. So you are taking moment of this part only, dm into x, where the whole part is considered. You have to, integration means you have to sum over all the elements. How do you integrate? You integrate from 0 to L. So m by L is a constant, it will come out 0 to L x dx, isn't it? So this is 1 by L, integration you know very well. So 1 by L, answer is L by 2. So where does the center of mass of this rod will lie? That is at the midpoint for uniform rod. So CM lies at the midpoint. Okay? CM lies at the midpoint. Now, how to find center of mass in the second case? When density, linear mass density varies according to this relation, total length of the rod given, mass is given 2 kg. So how to find it? It is 2x plus 3x square. Linear mass density means what? Linear mass density means gradually it's increasing, it is not fixed over there. Mass is gradually, it is not uniform one. Gradually it is increasing. But at a distance x, the linear mass density is what? Linear mass density 2x plus 3x square. So what you will do here? Take the elemental portion dx, same concept. From this end, distance of that, it is not distorted, it is rod, but non-uniform area of cross section. Mass is increasing, mass density increasing gradually. This linear mass you have to consider at a distance x. Then what is dm? Mass of the elemental portion. Tell. Linear mass density given per unit length is this much, 2x plus 3x square. Dx is a small part, so along dx it is not going to change. Dm is done. Now after this we have to find x bar. This one also one dimensional object. X bar, what's the formulation? This will be integration dm into x by total mass. And what will be limit of integration here? This into x dx by total mass. What is the limit of integration? Because x is changing from 0 to 20 centimeter. So integrate from 0 to 0.2. Clear? So this you have to integrate. Do it with me. 2x plus 3x square into x. Two x square dx.
2x cube by 3. 3x cube by 4 by 3.
Now substitute there 2x cube by 3. 3x square by 4. This mass you replace by 2 kg.
X to the power 4.
3. This is 3x cube. Yes, 3x4 by 4. 0.2. Substitute there. It will be 2 into 0.12 whole cube. 0.008 by 6. Because lower limit when you put x equal to 0, it will be 0 in both the cases, isn't it? It will be 0.0016. Am I correct? Check once. 0.2 to the power. Double 0 will be there. 0.0016. I am not going to simplify. Finish it. Concept you remember? Now the question is, these two questions I think all of you have done at school level only. But ring, how to find for a ring? Ring is two-dimensional or one-dimensional object? Third question was on ring. How to find center of mass of a semicircular ring? Ring means that part only there, no? This portion is not there. We are just drawing to get the idea of ring. This is the ring. Its mass given, radius given. You have to find its position of center of mass. How to select the elemental portion here? There is a question. The elemental portion will be like this. But from one end distance you cannot take x because it is along curve. Then which one will be easier here? To find center of mass, you go by polar form. This point PQ is the elemental portion for the ring. This is elementary portion, its angular location be theta, and the angle the other end makes, that is d theta. Clear? So this part is theta, and this angle center BO, angle POQ equal to d theta. Am I correct? This angle is d theta. Clear? What is the mass of elemental portion? Total mass given and radius given. PQ is the elemental portion. Its mass equal to what? PQ length you write. What is the length of PQ? R d theta. You all have done trigonometry. S equal to R theta relation is there. Mass per unit length is what? M by L. L is what? Pi R. Isn't it? So mass is going to be small m into PQ length is R d theta. This is mass per unit length. We are multiplying with the length. So m by pi r into r d theta. So what will happen? It is m by pi d theta. Clear? Understood? Now we have to write center of mass of, x coordinate of center of mass and y coordinate. How to write x coordinate? We need the x coordinate of this point P. How to draw perpendicular here? So this portion is x and this is y. This is your y axis. Let this be the x axis. Clear? Understood? So how to get the value of x there? In figure, x by r equal to cos theta. Agree? X is, this point has coordinates x and y. So x will be r cos theta. Isn't it? The value of x is r cos theta. What is y by r? Y by r is sin theta. So y equal to r sin theta. Now finding will be easier because I got the value of dm here. What to do? Next step? For rigid body, what formula do I apply? I am calculating here because everything will be in this place only. X bar is what? Tell. Integration of x dm by total mass. Substitute the value of x over there. X is what? R cos theta. Dm is what? We got here. Dm is m by pi d theta. This divided by total mass. What should be the limit of integration? Because you have to integrate over the whole this is a two-dimensional rigid body, no? For two-dimensional rigid body, we have to do it along the whole length which lies in 2D coordinate. What should be limit of integration? How can I cover the whole semicircular part? Hey, what's your face? Then come here. What will be the value of theta here? From this end we have started. We have to cover the whole dot. It will be from 0 to pi. So x bar will be r by pi cos theta d theta. What is integration of cos theta? Sin theta you know. Then upper limit is what? Sin pi minus sin 0. So x bar equal to 0 here. Am I correct? Done? No x coordinate. Can you try for y coordinate? I will wait for that. Find the y coordinate of center of mass. Do it. Using the same concept. Find y coordinate. Try once. Similar way, because I believe that you are all are doing it with me. You should do some steps. Do find y coordinate. Tell me the value. I will wait till then. Same way you multiply by y. Y is r sin theta. I have written. I just expect the answer from you. No. Did not do anything. Yes. No. It is not 0. Not serious in studies. It will be 2 by pi. Check once.
2 by pi?
Yeah. Mentally it can be calculated only. Y bar I am writing here. It is y dm, right, 0 to pi. Same way, this divided by total mass. What is y over there? It was r sin theta d theta, dm into that, no? dm. You multiply dm. dm is what? m by pi d theta. And y is what? This is r sin theta. This divided by m. Limit of integration 0 to pi. So m getting cancelled. R by pi sin theta integration is minus cos theta minus cos pi is 1 minus plus 1. So answer is 2r by pi. So for a semicircular ring, the center of mass for a ring, the center of mass will lie from the center of the ring at a height what? 2r by pi. Please. Cos pi is cos 180. Cos 180 is minus 1. So minus minus plus, that's why. Please try to pay attention here. So it is at a height 0, 2r by pi. Okay? You will be using the same concept for the semicircular disc. That fourth one I have given now. You do it for that. For a disc, you prove that. I am telling you the answer also, but you need to try at home. Prove that center of mass of semicircular disc. This is semicircular disc of radius r will be lying at a height 0, 4r by 3 pi. Okay? Prove it. So how do you take the elemental portion? I can help that part also. Divide into infinite number of small parts, and elemental part is a ring. Elemental portion will be a ring. For that ring, center of mass is just found. Okay? This is elemental part. Okay? This has thickness say dx. Then you write the center of mass of this and integrate over the whole portion. Try. Next, let us do motion of center of mass. Motion of center of mass. We start with this expression that Cm equal to center of mass position. I am writing R Cm vector m1 r1 plus m2 r2 plus mn rn by m1 m2 mn. Okay, this is RCM, I mean position of Cm. To get the velocity, we differentiate this relation with respect to t. drcm by dt is what? This is a constant. You can keep it outside. m1, m2, mn. How will I get here? dr1 by dt, dr2 by dt. I will be differentiating term by term in the numerator. This is what? mn drn by dt. Clear? What is dr1 by dt? It consists of many particles, m1, m2, mn. dr1 by dt is velocity of first particle. So write Vcm equal to m1 v1 plus m2 v2 plus mn vn m1 m2 up to mn. Clear? This is velocity of center of mass. This is nothing but sigma mi vi by sigma mi, I equal to 1 to n. Clear? This stands for velocity of center of mass. Okay? Now, I have asked you a question already. Prove that before you proving that, just go for another one. Velocity of center of mass you have understood. Similarly, if you differentiate again, I am just copying that step. Similarly, differentiating again with respect to t, we can show that same manner. That's why I am not doing. It will be m1a1 plus m2a2 by m1, m2 up to mn. Agree or not? Acceleration of center of mass done. Now I can ask you this question. Prove that in absence of any external force, velocity of center of mass remains constant, remains the same. I'll show you one very interesting application on it, but first you prove this. Okay, you have forthcoming school examinations, get ready for that. This question may arise. In absence of any external force, velocity of center of mass remains the same. Done. You do it for two body system. I am giving you some relief here, hint from my side. Do it for a two body system. This will be easier for you. And take the help of Newtonian mechanics. Try. Write the expression for acceleration for two body system in absence of external force. What is acceleration of center of mass? Right? For a two body system, ACM is what? M1A1, this divided by M1 plus M2. External force absent. It means they are in motion for internal forces only. So this mass M1, its acceleration is A1. This mass M2, its acceleration due to internal force is A2, M2. Okay? Just showing diagram the situation. This is enough. It may be 2 mark question maximum, no? But you have to answer. Now tell me what is A1 here. F12 stands for force experienced by M1, force experienced by M1 due to M2. Similarly, you take F21 equal to force experienced by M2 due to M1. Now can you try yourselves? Do it. do it fast. Done, it's coming. Check once. You just put it there. ACM equal to what? This you write. A1 will be what in this diagram? A1 acceleration of first body will be force experienced by M1 due to M2. This by M1. A2 will be what? F21 by M2. So ACM will be what? M1 F12 by M1 plus M2, this divided by, so this is nothing but this by, now F12 equal to minus F21, this you know, so this will be 0. So ACM equal to 0. What does this imply? d dt of VCM equal to 0. VCM equal to a constant. Clear? What is the physical significance of this thing? That velocity of center of mass constant. How do you interpret this? Suppose initially it is at rest. What will happen to it? It will remain at rest forever. Even for two body system, two masses are being dispersed in different directions, but velocity of center of mass remains the same. Can you give an example? VCM constant means what? What is VCM? Tell. VCM value is what? Forgot. M1, V1, M2, V2, all that constant, no? You take two body system, M1, V1, M2, V2 by M1 plus M2. You said this VCM will be 0 in absence of external force. VCM 0 means M1 V1 plus, now physics starts, M2 V2 is not mathematics only, no, concept is also there. M1 V1 plus M2 V2 0. Could you explain? What is the physical significance? When a bomb burst, it was at rest. Particles getting dispersed. Okay? They are going in different directions. Very interestingly, you have to notice that if it splits into two parts, then one part exactly opposite to the other. This is the law of nature. It will never be denied. If it is in three particles, if it splits into three particles, bomb bursts into three particles. What will happen? Two particles going this way. The third particle will be in a direction opposite to the resultant direction of motion.
So we can say that the momentum will be equal and opposite direction.
Yes, no, yes, that way only. It is generalization here for system of particles. One going this way. If it bursts into three pieces, the third one has to go this manner. Okay? This M1 V1, M2 V2, then M3 V3 will be 0. if one going this way with velocity m1 v1, the other one going this way m2 v2, the resultant will go this way. The third particle m3 v3 will be moving in a direction opposite to it. Although the velocity of center of mass is 0, it is at rest over there, but particles will move in different directions. If it bursts here, what will happen? Two particles, one has to go this way, one has to go this way. They will follow projectile path and will strike the ground after some time. Isn't it? Practical question may arise based on this. I will discuss numerical question based on this, but the concept you keep in your mind first. So now the question arises, can we apply Newton's second law of motion for system of particles also? What have you done about system of particles so far? Just you have studied center of mass, isn't it? So let us show that the Newton's second law of motion can be used for system of particles also. To show that, this was our first question today's class. To show that Newton's second law can be used for system of particles also. Will you try once first? Try. I am giving you one information here, that velocity of center of mass you got, velocity of center of mass, acceleration of center of mass you got. What is that? ACM equal to, I am writing in short, sigma mi ai by sigma mi. Here I equal to 1 to n. This is also I equal to 1 to n. So this implies sigma mi ai. Sigma mi stands for what? Total mass, isn't it? Sigma mi stands for total mass. So sigma mi ai equal to cross multiply m into ACM. Okay? M into ACM. This implies m into ACM equal to, just split this one. It is what? First one, m1a1. m1a1 means what? Force acting on first particle. m2a2 m1a1 is what? F1, force for acting on first particle. m2a2 force acting on second particle. mnn force acting on third particle. So now can I state that these are external forces? Can I state that instead of considering masses of particles separately, if we assume that center of mass situated at some place moving with acceleration ACM under the action of these forces, this m into ACM is what? Mass into acceleration. Whose mass into acceleration? This is center of mass. The whole mass situated at the position of center of mass moving with acceleration ACM. So net force on it is equal to resultant of all the forces acted on all individual particles. So for a system of particles, say they are confined in this region, here only, here, all this system of particles. This system of particle is in motion means center of mass is in motion, its acceleration given by this. Okay, so this mass into acceleration now going to be what? F external. This means what? This is Newton's second law. You can use second law for system of particles also. Similarly, you can discuss with what? The momentum. With momentum, you try to explain, you think how to get this equation by using the concept of momentum. Same thing. First, to define linear momentum of system of particles. Can you define it? Linear momenta of a system of particles. P equal to what? Net momenta is what? Net momenta is what? M1 V1, M2 V2. Net momenta we are writing. All the particles, mass M1, M2, Mn, all are there. They have different velocities. This is net momentum. M1 V1, M2 V2, Mn Vn. Now this M1 V1, M2 V2, Mn Vn, where have you seen? When you are finding VCM, isn't it? M into VCM, or I remind you in details. What is VCM? M1 V1, Mn Vn by total mass cross multiplied. Therefore, M VCM equal to what? P. M VCM is equal to P, isn't it? Now, if you differentiate this with respect to T, what do you get? M ddt of VCM equal to dP by dt. Ddt of VCM what? Just to have seen. M into ACM, dP by dt is what? F external. This one also supports that dP by dt is net rate of change of momentum. So acceleration of all the particles you need not consider separately. That for system of particles, center of mass is enough. Center of mass may be at rest, all those different particles moving in different directions with different velocities. All these things may arise. Okay, as you have to finish the whole syllabus of rotational mechanics now in this session, so I will be continuing theory part. Problems we will have another session. Okay, next part we are going to learn torque or moment of a force. What is torque or moment of force? Force plays important role for acceleration, isn't it? Torque plays the same role in case of rigid body. I hope all of you know cross product of vector. If you don't know, then I have to do it again by using that determinant. How to calculate? Know it. A cross B, A cross B. Know it, or I have to remind you. I just tell you. No, dot product different, cross product different. This is A vector, this is B vector. If you curl the finger of your right hand from A vector to B vector, then cross product direction is this way, isn't it? Along the plane perpendicular to the plane of A and B. What is A cross B by definition? Tell. AB sin theta n cap, isn't it? And I just remind you this part, and suppose A equal to A1I plus A2J plus A3K, and B equal to B1I B2J B3K. So A cross B will be what? It is given by the determinant IJK. Know it or not? A1, A2, A3. Done. This one done? Not done. So this cross product is required. This is A1, A2, A3. B1, B2, B3. What is the result here? Yes, A2, B3 minus into I cap. Next. Minus A1, B3 J cap plus A1, B2 minus A2, B1 K cap. So what I want to say on it, what concept we need here in rotational mechanics from torque, from cross product. Number one concept is cross product of two vectors will lie in different plane, perpendicular to the plane of two vectors A and B. And number two, cross product is a vector quantity, it is not scalar quantity. Work done was a scalar quantity, this is a vector quantity. And magnitude of cross product given by what? This is AB sin theta mod n cap. This is just AB sin theta. Okay? And geometrically, what does it represent? Some topics in gravitation also you need the concept of cross product, angular momentum, all these things. Know this one first. AB sin theta geometrically how to represent? AB sin theta geometrically what does it represent? I just remind you. This is vector A. Which one? This one. This one vector B. OACB is the parallelogram. What is the area of this parallelogram? This angle with theta. Area of the parallelogram, area of OACB will be what? Half into A into BM. BM is B sin theta. Just to have seen that it is mod of A cross B. Remember this concept also. Okay? So what is geometrical meaning of cross product? It represents, therefore, mod A cross B represent the area of a parallelogram whose adjacent sides are what? adjacent sides are A vector and B vector.
So now you say half in the front and the rest will be half.
Yes, yes, half A cross B, of course. No, this is not
No,
half.
it's not half.
Area will not be half, it is A cross B only. Half is area of triangle, no? Just mod A cross B represent the area of a parallelogram whose adjacent sides are A and B. Clear? This session will be elongated. Okay? Afterwards. So you need to know now torque and then angular momentum. What is torque? Torque or moment of force. How do we account for this? Torque or moment of force? Achha, one thing, let me tell you the introduction. When you are opening a door, is the force responsible or something else? For opening the door, is force responsible? Force is definitely responsible, but you just imagine the force you applied at the hinge. Can you open the window or door? No. Force you applied at any other point other than the hinge, some distance away, then only it can. So we can say that effect of force, that is going to be torque in our discussion, is going to be responsible for that. The torque will play the same role as that of force in Newtonian mechanics. Torque is the rotational effect of force. Force definitely involved, but you cannot say that force is the factor which can rotate a rigid body. No. For rotation, torque is required. So we must know what is torque of force. Let us take a rigid body. Imagine there is a rigid body like this. Okay, just imagine. Rigid body is there. You have applied force at a point here. This is the line of action of force. Point of application is P here. We want to define moment of this force. Force is F. Whenever you define moment of force, you need a point. About that, moment will be there. I just tell you. Do you think rotational effect of this pen will be same when we apply force here or here? No. Rotational effect will be more here. Rotational effect will be less here. We will say that more torque act here, less torque act here. Clear? So for the rotation of the rigid body, you need to know what is the value of torque. You just find torque about torque or moment of force F about the point O. How do I account for this? This is defined as force into length of lever arm. Lever arm. What is the lever arm? You have calculated, you are going to calculate torque about the point O. From there, you draw perpendicular. OM is the perpendicular. Okay? Then force is what? F. Length of lever arm is what? OM. Suppose distance of OP equal to R, then this is going to be OM by R equal to, if this angle is theta, then OM by R equal to sin theta. So OM equal to R sin theta. Therefore, this torque we denote by the letter tau. So tau is RF sin theta. This is what? Just we have seen, it is cross product of R and F, isn't it? So if we write in vector, tau vector will be R cross F vector. Torque or moment of force is R cross F. Clear? Now, you just think with different manner. When you have applied a force here, just consider the rigid body taken here. I am just drawing the boundary here. This force is F, this is the point O, and the angle you have taken theta. Then this force F we extend, this one also theta, you agree? Then F has component F cos theta this way and component F sin theta this way. F sin theta is what? In what direction? It is perpendicular to the force. So which component of force effect you are going to consider here? That will be F cos theta or F sin theta. Wait a minute, sorry. Just a minute, please. If we have applied this manner, wait. If we have applied this manner, so component this way is what? This component is F cos theta and this one is what? F sin theta. You agree? Don't you see that F sin theta perpendicular? So this F sin theta is responsible for the torque. F sin theta is component along the radius vector. So when you consider moment of force, you will always take the component which is perpendicular to the radius vector. Okay? Torque is R into F sin theta. Now tell me, what is the effect of this force on the rigid body? It will rotate in what direction? If this is the rigid body, you are considering the point O here. Along which this force? If I keep this rigid body fixed, by the action of this force, in what direction it will rotate? If you keep fixed here, suppose this point O is here, then for what it will rotate? It will not rotate due to F cos theta. F cos theta has no contribution. It is contribution of F sin theta. So by the action of torque, the rigid body will rotate perpendicular to the radius vector. By the action of torque, rigid body rotates perpendicular to R vector. But there is a consideration. What consideration? Rigid body has no rotational motion. It is performing only translational motion. This happens when? Assume the rigid body performs rotational motion only. You think no, any object we are applying a force. Who told you that it will be rotating in perpendicular direction only? No. If we stop its translational motion, only rotational motion is there, then it has to rotate in that direction, no other way. Okay? This torque may be clockwise, this torque may be anti-clockwise. I can show you in diagram how these torques are responsible for balancing a stick. There is a pivot here. There is a pivot and there is a rod. On this rod, you are applying two loads. Load W1 here and the load W2 here. This is the pivot. Load W2 is there. Okay? Can you make this rod balanced over there? If W1, W2 same, then pivot must be at the midpoint. Pivot must be acting at the midpoint. But if they are of different weight, pivot will be at different position. Why? Let me explain. Due to this weight, there will be torque acting on it. In what direction the torque will act? This length be L1 and this length be L2. Assume that length of those two arms be L1 and L2. Then how can you make it balance? First you think this. This has a rotational effect, but this rotational effect will rotate the rod in clockwise sense. This one also has a rotational effect. This will rotate in anti-clockwise sense. Now to keep it balanced, to keep the rod balanced, what to do? Net clockwise torque must be equal to what? Net anti-clockwise torque. What is net clockwise torque here? How do I account for this? Tell. Weight into length, W2 into L1 should be equal to W1 into L2. Therefore, W2 by L2, W1 by L1. The principle we have used here, that is called principle of moment. This is known as principle of moment. With what point of view arise? The rigid body is not rotating, it is balancing. It is in rotational equilibrium. So I have entered this term here, rotational equilibrium. Is there any translational equilibrium? What is that? Yes. Translational equilibrium is there, where net force is zero. It maintains uniform velocity, law of inertia. What is rotational equilibrium then? Rotational equilibrium states that net torque on rigid body should be equal to zero. So equilibrium of rigid body is of two different types. What is that? Equilibrium of rigid bodies. What is that? Tau, net tau external should be 0. I equal to n to n, that is net tau clockwise should be equal to net tau anti-clockwise. This is one condition. This is number 2 condition actually. And number 1 condition is what? This rotational motion is ensured that it is in rotational equilibrium. You have to ensure translational equilibrium also. This is the condition for rotational equilibrium, and this is condition for what? Translational equilibrium. What is that? Sigma F external should be 0. Net external force should be 0. Net external torque. In this balancing condition only, if you applied external force, can you keep it balanced? No. Resultant external force should not be there. It is there true, no? See, no. If you apply translational equilibrium here, what is the reaction over there? R upward. What is the weight of the body? W1 plus W2. We have assumed that rod is weightless. Otherwise, if it is weight, this R will be equal to net weight downward. Clear? So, net torque acting on a rigid body will be what? We will calculate that. Single particle you have understood. Now go for angular momentum. Just 15-20 minutes more. Okay? Let us find angular momentum. Just get the idea. Angular momentum of a particle. So moment of force you have understood. Rotational effect. Torque or moment of force, same thing. For rotation of rigid body, torque is responsible. If translational equilibrium is established, then the rotation will be what? Or if you keep the rigid body fixed, then rotation will be in a direction perpendicular to radius vector. Along the direction of radius vector, it never rotates. It will be perpendicular. I am coming back to explain omega concept for rigid body. But okay, let me tell you what is relation between. First do this part. Angular momentum of a particle. Let a particle of mass mi, mi, moving with velocity vi. Okay. Angular momentum, what is the term here? That L, small l, for a particle you write Li. We are going to define Li equal to Pi into R perpendicular. What is that? Suppose mass m moving in this direction with velocity v. We want to define Li for angular momentum of ith particle. Okay. This mass mi moving with velocity vi. What is angular momentum about the point O? How do you find this? Angular momentum about O. Mass mi moving with vi. Okay. Angular momentum will be the same manner. This linear momentum acting this manner, produce it backward. You are going to calculate angular momentum about which point? About the point O. So angular momentum about O will be linear momentum into this perpendicular distance. Li will be what? Tell Pi into OM. Again the length of lever arm. If radius vector directed this way and angle between these two directions theta, this is also theta, then it is pi into Ri sin theta. You can take sin theta I also, all for ith particle. And if we use vector, Li vector will be Ri cross pi. Okay, this is also a vector quantity. Clear? This is for single particle. A particle of momentum pi moving at a, that Ri is the position vector, then cross product of these two will give you angular momentum. So angular momentum brings what? Angular momentum brings what? Angular momentum, we are going to see that rate of change of angular momentum is equal to external torque. Okay? For system of particles, we need ith particle, all these things. For single particle, what to write? Tell. Mass m going with velocity v. Then p is what? mv. So angular momentum L is what? Tell. mv into r sin theta. What is r? You have considered about this point O. Same thing for a single particle. This is theta, this is also theta, so r cross p. L is r cross p for a single particle. For ith particle I am coming back. For a single particle, what happens? L equal to r cross p. Got it? Now differentiating with respect to t, dl by dt. This is another derivation or another concept which you need in gravitation to derive Kepler's second law of planetary motion. dl by dt will be what? ddt of r cross p. Clear? dl by dt is ddt of r cross p. Suppose a question arises this manner, prove that for a single particle, the rate of change of angular momentum is equal to torque acting on it. Torque expression you have studied for single particle r cross f. If you can prove that dl by dt equal to r cross f, then the proof is done for single particle. Am I clear? I am going to do that. So this definition you have understood. Now we are differentiating with respect to t. Both are variable quantity over there on right side. You write ddt of r cross p plus r cos dp by dt. Clear? dl by dt is ddt of r, just product rule of differentiation. What is dl by dt? Tell. ddt of rate of change of position vector, it is velocity vector. V is dl by dt. So write V over there. Cross P is what? P is mv, you know. Plus r cross dp by dt. How will I write dp by dt? What is dp by dt? Force. Rate of change of momentum r cross f. Just v cross v. Same vector. What is the cross product? ab sin theta. So vv sin 0. Same direction, no? So this part going to be 0. And this part is what? Tau external. Have you done it or not? So dl by dt is equal to tau external. Write in word. Therefore, rate of change of angular momentum of a particle is equal to the external torque acted on it is equal to the external torque acted on it. Okay? So this is for single particle. Today we are studying not single particle, mainly for group of particles, system of particles. But if this is a school based question to check your knowledge whether you know it, and teacher is very kind hearted, this question they might have asked 2 mark or 3 marks question. Okay? Now let us go for system of particles. For a system of particles, how do you write? L, net angular momentum, equal to L1, L2 up to Ln. This is nothing but sigma Li, I equal to 1 to n. You agree or not? What is Li? Tell. Angular momentum. This we have written before. Ri cross pi. For single particle I wrote. I started that first. For arbitrary particle I started that first. Li equal to Ri cross pi you have defined also here. Same expression I am using here. So Li is Ri cross pi. Now differentiate both sides again. All like previous thing, dLi by dt. What can I write? It is ddt of dLi by dt you want to write. I mean dL by dt, not dLi by dt. What can you write? ddt of sigma I equal to 1 Li. Isn't it? So this is nothing but sigma dLi by dt. What is dLi by dt? Tell. For single particle we got tau external. So what to write here? I equal to 1 to n sigma tau I external. You agree or not? So dL by dt, write your conclusion. Therefore, for system of particles also, rate of change of angular momentum is the net external torque or net torque. You just write net torque. External, internal, that part I will clarify. This tau I is what now? Tau external plus tau internal. Tau internal will be equal to 0. External torque get cancelled for each particle. M1 due to M2, M2 due to, they get cancelled. So dL by dt will be what? dL by dt will be what? That is net torque, that is tau external. This is net torque, no? This is net torque. Tau external plus tau internal. Tau external can you write? How can you write? It is sigma Ri cross F external. And tau internal, how can you write? Sigma Ri cross F internal. Isn't it? After this, right, if we assume net external torque 0, then normally it happens for rigid body, they get cancelled in pair. So dL by dt is going to be the external torque, that is tau external. If we assume that internal torque get cancelled in pairs, then we have dl by dt equal to tau external only. Now, how do I account for last topic? How do I account for conservation of angular momentum? This we are doing for system of particle, not rigid body. Next session we will be doing it for rigid body only. Okay? It's a big chapter. For a system of particles, so you put a heading over there, principle of conservation of angular momentum for a system of particles. Principle of conservation of angular momentum for a system of particles. See how I am answering? We have dl by dt equal to tau external, just we have seen. Now if tau external equal to 0, what will happen? We have dl by dt equal to 0. This implies what? L equal to a constant. This implies L equal to constant. Done. So write the principle. Therefore, in absence of any external torque, so in absence of any external torque, angular momentum remains conserved. Okay? Angular momentum remains conserved in absence of any external torque. Next session we will be discussing particle to system of particle we have done in the first session. What we are supposed to do. Next session we will be doing it for rigid body. Okay, that is the most interesting part of rotational dynamics. We are doing it for rigid bodies only, but I have shown you how to follow the steps for one particle, then for system of particles. Whatever valid for one particle, true for system of particles. Newtonian mechanics, second law for one particle. What you have done there? You have considered a big object as a particle only. Behavior is like a particle. That particle is a point mass without any size. Size you have ignored. Particle dynamics. Here we are considering true rigid body. Going to consider for that system of particles. Rigid body also system of particles, but more organized. So what it is going to happen for rigid body, that I will be discussing. Okay, done.